Good morning, everybody. Welcome back to lecture number 3. Again, please make sure you download the latest revision. Currently, we are at revision, if you're watching, revision 3. Last time we talked about the history. Now, who did not read the article? All of you didn't read the article. One takeaway from the article is, I want to give you some more information, is the following. Yes, Tesla's ideas won, but did he win? No. He lost. Edison's idea lost, but did he win?
Yes.
So in principle, both of them, they won. One won economically, one won and conceptually. This touches a very important point. In technology or engineering, there is always financial institutions backing up whatever we have. In engineering concepts, we have also lawyers. And as a matter of fact, if you graduate next year and you don't want to do engineering, you can become a lawyer. You know that? No?
No.
You don't know? Well, as a matter of fact, one of the smartest lawyers are the engineers. So if you're done with electrical engineering, you have a chance to go to law school. Usually those law schools they give you a little bit more courses, prerequisites. So it will take you one more year. But then you will become a lawyer. And your job maybe will be to defend the company's IP, intellectual properties, disputes, from technical understanding. You can argue this a solid contribution to the company that owns it. I actually have one friend from my high school. I remember he graduated from Australia and he joined Aramco, and he continued his education in law school. He became a lawyer for Aramco. I think he was mechanical or electrical, I'm not sure. So think about it. What was that? G, T, D. And D is anything below? Do not study the slides. Later on it's going to be hard. Below 69 volts distribution. That's the key number. It's similar to knowing the voltage frequency is 60 hertz. Anything below 69 is what? Like 69 itself. The transmission. Okay? Recall, in single-phase circuits, we introduced it last time. Why? Because in EET60, we will have a three-phase system. We will draw the equivalent single-phase circuit model. Get it? Okay. Last time we talked about this impedance J times X. What was the formula of X? Omega L. What is the formula for X for capacitors? 1 over omega C. If you want to include the J, it's going to be minus J over omega C or 1 over J omega C. Go back to the slides. Okay? Get it? Last time we also talked about lagging and leading. We said in this particular scenario for an inductive load, I lags the V. If this was a capacitor, I would be leading the V. What if we have a combo? Depends which one is bigger. Okay? We will see an example. Who did not bring the calculator? Who did not bring it? For those who did not bring it, make sure you check with your colleague next to you how to do the numerical analysis. Okay, always calculators, always. Always. We will be solving examples and I'll ask you to do it using calculator. Please, make sure it's in degrees. Last time we talked about the impedance and how you get theta, and I told you, theta will be positive for inductors, negative for capacitors. Last time we talked about the Ohm's law, equivalent in phasor notation. where V divided by Z, or the impedance, is going to give you the current. So keep in mind, I is a phasor. Phasor يعني إيش? Basically a complex number. رقم مركب. V is a phasor. Magnitude and angle. I is a phasor. And also Z is a phasor. Magnitude and angle. This is how to get its magnitude. This is how to get its angle. Please, we will solve EE360 using phasors. Calculators should be available. I have decided to remove the other plot. So let's just keep this figure. Recall, what was the total power of the system? Total power is V times I. Okay? We call it instantaneous power. We took this in E 201, 213, 203. V times I, we did the trigonometry, and then we ended up with three quantities. P1, P2, P3. P1, does it change with time? No. So P1 is what? Constant. So it is calculated by V peak? No. VRMS phase. V phase times I phase times cosine theta. So this is a constant number. We call it the average power. It is the DC component of the instantaneous power. Then we have two quantities, P2 and P3. If you add P1 and P2, this is P1, you add it to P2, which is VRMS, IRMS, cosine theta, cosine to omega t. Keep in mind, this quantity is same as this quantity multiplied by cosine to omega t. And this quantity is similar, but you replace it with sines if you want to get familiar with it. Now, keep in mind that P1 plus P2 has an average value. P3 has an average value of 0. We call this quantity average power. We call this quantity the real power. So real power is what? P1 plus P2. The reactive power. What is the reactive power? Only P3. So average power, real power, which is the average power plus P times cosine, or minus P cosine to omega t. P3 is what? Minus, there is a minus sign, minus V phasor, I phasor, sine theta, sine to omega t. So, the first term P1 is constant and represents the average value of the power. The second term and the third term, if you add them together, they have an average value, and the sum of them is plotted in this figure and is representing the real power. The real power. The last quantity is the reactive power. Keep in mind, we define a new quantity, which is V phasor, I phasor, sine theta. Basically, if I take this, the P3, can I write P3 using this notation? P3 equal minus Q times sine 2 omega t, where Q is V phasor, I phasor, sine theta. So this is the amplitude of sine 2 omega t. We call this quantity reactive power, or Q, and it has a unit of bars. Voltage times amps, reactive. Voltage times amps, reactive. Get it? It's not only that, from where this Q comes from physics point of view, it comes from the stored electric field or magnetic field. Electric field is stored in capacitors. Magnetic field is stored where? In the inductors. When the signal propagates in the line, there is a reactive power due to these magnetism and electric field. And this is necessary to run the system. But you don't pay the bill for it. You only pay the bill for P1 plus P2, the real power. So Saudi Electricity Company charges you for what? For P1 plus P2. They don't charge you by P3, but it's their job to minimize P3 in the system to make it running, minimize the cost. Okay? So if electricity prices go up, it's not only because you consume, it might be can become more expensive because the reactive power is expensive. It's a burden for the company. Power factor. Power factor is a quality indicator of how good your voltage reaches the load, etc. And power factor has quantities roughly, I don't know, 0.8 all the way to 0.99 or 1. So in the exam, if I see power factor 1.05, that is wrong. Because a cosine can never be larger than 1. Also, if I see quantity too small, 0.0003, tells me that you had some calculations there. When you develop a solution, make sure it makes sense. Okay, this is one of the skills that my goal is to teach you during this course. Now, power factor, you're already familiar with it. Let's review also the apparent or complex power. Complex power is you take V phasor, you multiply it with the I conjugate. We'll do exercise. Last lecture, what was our phasor? 110 angle? No, 30. Do it by calculator. How to get the conjugate? You don't have? I'm going to explain. النجمة هذه معناها conjugate of I. Okay? مو على ال V conjugate على I. تاخذ ال V, تحسب ال I, then you take its conjugate, then you multiply it مع ال V. So I'm teaching you how to get the conjugate. Now when you run your calculations, let's say you ended up with example 110 angle 30. Barakat. Get it? Who doesn't have a calculator? Sit with your friend. لا تستحي. How to get the conjugate?
Minus 1 over.
Yeah, minus, but when you run numerical examples, you want to run efficient. There is a way to do it by calculator. Do you know how?
Shift 1 over. Shift 2 2.
No, not 1 over.
Shift 2 2.
Shift 2, and then you have 4 options. You pick option conj, number 2. And then shift 2 2. What do you put in parentheses? You put answer. You already stored 110 angle 30 as answer. So learn the habit of storing your answers and putting them in the conjugate. So 110 angle 30. If you store it, so 110 angle 30, what is its conjugate?
55.3 minus 55J.
Okay, what was before 55 root 3 plus J 55?
Yes.
If you do the conjugate in Najma, what will happen? 55 square root 3 minus J 55. So what is happening here is you have two options. عندك الpolar form, عندك الrectangular form. If you're in the polar form, you change the angle to its negative. For rectangular form, every J has to be minus J. If you have more than one term with J's, every J should be replaced with a minus J. If you're doing calculator, shift 2 2 and then put answer. Answer is your last calculation. It is a very important feature because sometimes the students write the correct number on paper, but they put it wrong in the calculator. So to minimize this from happening, it happened to me when I was a student too. Put shift answer to verify. And put shift 2 2 and type whatever you wrote on the paper and see if they are equal or not. Get it? So now you know the conjugate. So when I tell you S equal VI conjugate, you calculate V, calculate I, you calculate its conjugate, you multiply both of them, you get S. S is a complex number, 2. V is a complex number, I is a complex number. So it has another way of calling it is P plus JQ. And what's the unit? VA. Voltage times amp. What's the unit of P? Watt. What's the unit of Q? VA little r. What's the unit of S? VA. Get it?
Yes.
Now, we have the power triangle. The power triangle is useful because we can use trigonometry. For example, tan theta is Q over P. We can get theta, we can get Q, we can get... So if you know two quantities, you can get the other Q. I think so, I'm not sure. By the way, I have to acknowledge that I'm not a mathematician, okay? So sometimes I forget things. So how many... What is the minimum things you need to know in order to find the rest?
2.
2?
S will be Q squared plus...
نبغى في التواصل
Yes.
تبي الاس ثيتا تقدر تحسبها من التان والكوساين والساين of theta. You can get sine inverse, theta inverse, and always get to the angle below 180. below 90. No 90. And هنا عندك 90 always. This is 90, these two will be the summation of them 90. عشان يصير مجموع زوايا المثلث كم؟ قدرات 80. So you need two quantities to get the other two. Sometimes we give you S, we give you theta, tell you what is P, what is Q. Sometimes we give you Q and theta, tell you what is P.
From the minus there, I can know that the load is inductive.
No,
No?
you can't make, no. You can't make such a thing. To know if it's inductive or not is, the only way is by theta. Tan inverse. And so to get theta, you need to, basically theta is minus 30, because it's minus 30, not because it's negative. This theta is inductive, this theta, I mean, it's inductive, but if you take the conjugate, it doesn't mean it becomes capacitor, لا. But in your calculation, it's just negative angle, it might be. Now,
Okay.
you can't generalize, يعني احنا أخذنا الconjugate. It's not necessarily true. Okay? Okay. Any question? Let's solve this example. Calculators, please. Before you solve every problem in E360, what is the first step you need to do?
Check the calculator is complex.
Well, check if your calculator is in degrees. That's good enough. But always read the question. For the circuit shown below, what is written? We have 1 phi. What does 1 phi mean?
One phase?
One phase. So he's telling you, I am showing you one phase circuit. What is 120 volts? Is it the peak? Is it the RMS? Is it the magnitude? It is the RMS. So always in power systems, we love RMS. So all say with me, we love RMS. ما حد يجي يسأل في الاختبار يقول هذه peak ولا RMS, because we all love, unless otherwise specified, it is an RMS value, okay?
Yes.
Now, 120 RMS. What is the frequency?
16.
So can I write the time domain expression? Square root of 2 times 120 times sine omega is 2 pi 60 t. Does he tell me any information about the phase shift? So if he doesn't tell me, I know it's the reference, so the phase is 0. So I don't add a phase shift. The question asks us about get the RMS value of the supply current. In this circuit, where is the current?
Sure.
Top, right, bottom.
Going clockwise.
Which branch? Top.
Top.
Is this I a phasor or RMS using this notation?
RMS.
It is a phasor. So this I is a phasor, is a complex number. So I really need to go back to the previous formula. So I phasor is V phasor over Z phasor. What is V phasor? This is V of T. What is V phasor? 120 angle. What is Z equivalent phasor?
The total.
Let's do the total.
دكتور كيف عرفنا ان فيزر مو RMS؟
كيف عرفنا؟ لأنه لو كان RMS بيحط في الإكزامبل حقه sub P. Plus إنه the actual current that goes is always RMS, is always phasor. يعني لما يعطيك الامبيدنس as phasor الفولتج لازم تحطها phasor والكارنت راح يصير phasor. ما تقدر تخلط RMS على كيفك وتحط هنا الامبيدنس phasor يعني complex وتحط لي الكارنت RMS والفولتج RMS. ما تضبط النات. You have to be consistent. فلأن حط الكارنت يمشي هنا من النوتيشن حقت الاكزامبل تعرف ان هذا phasor. انه هو في له magnitude وفي له angle يعني complex number. So what is Z equivalent? It's very easy. 8 plus J times 10 minus 4 times J. So Z equivalent is what? 8 plus J10 minus 4J. How do I know it's minus J4? From the formula. Jx equal J omega L. Jx of C is what? 1 over J omega C, which is minus J times 1 over omega C, e to 13. Basically, you put minus J for a capacitor plus J for.
So here you mentioned that V equal 120 angle 0.
Correct, volts.
This is the RMS.
No, that's the RMS is only 120. If you combine it with angle 0,
Phasor.
that is the phasor.
And how did you get that? And how did you write that equation?
The time domain
Yes.
is you put here V phasor, you put here phase shift. And this is standard in all power systems.
Square root of 2 and.
Yeah, it is this formula. Map it with this formula, okay? Let's continue, ya shabab. What is Z? Calculator, please. I want Z in phasor.
8 plus 6.
Well, let's agree. You want to do polar or rectangular? Both are correct. You want to mix polar and let's mix it. It works. So what is Z? 8 plus J 6 ohm. What is V? 120 angle 0. You can write it as 120 plus J 0. So what is I? Divide this by that using calculator.
12 angle minus 36.
7.5 minus 7.5 G.
Let's use polar. For answers, it's better to use polar.
كم قيمة الأوميجا؟
Omega, I already told you before. 2 pi 6 377. What is omega?
2 باي الفريكونسي بس جي اوميجا ال المفروض ما يكون جيتين على طول تضرب في الاوميجا
What is given to you here is 10 which is omega L.
على طول.
Get it? Read the unit. What's the unit? Ohm. Get it? I had a mistake. I didn't put the unit. Okay? 12 angle minus 36.87 degrees amp. So, read the question. What is the RMS value of the supply current? 12 amp. It's not 12 angle. This is the phase. Can you get it?
Yes.
What is the RMS value of the current? No, talk.
I divide the.
No. Tell me, what's the RMS value of this current?
It's 12 without the amp.
Just 12 amps, okay? Problem 2, he's asking you to write them in time domain. He's doing that for you. It's a square root of 2 times 120 sine of that. Square root of 212 sine of omega t. You take whatever angle here, you put it there. Okay? Don't confuse yourself with the notation here, because in the notation here, it tells you minus theta. So minus theta is the whole angle of the current. كلها minus theta. Get it? معناتها ثيتا هنا is 36.87. فعشان ما نلخبط بعض whatever angle تحطها هنا حطها بإشارتها داخل الساين. واضح؟ Theta is what? Plus 36. So if you look at the time domain expression, this minus omega t, this minus theta, حطيناها كلها وين؟ minus 36. الانجل حقت الكرنت كلها مع السالب حطيناها بإشارتها اوميجا تي minus theta. So theta is 36.9. فعشان ما تلخبط الرقم بإشارته حطه الفيز كله. لا تحط ماينس تحذير اوكي؟ كيف؟ What I'm telling you معلش is الكرنت اللي يطلع هنا عندك هو اللي تحطه بالفيس شيفت. لو تتبع الفورمولا I as written as something minus theta. الثيتا في الحسبة هذه هي 36.9 فتصير ماينس ثيتا تبقى زي ما هي الآن. الزاوية اللي تطلع لك في الكرنت تحطها كلها بدون ما تغير الإشارة. علم؟ تمام؟ Agreement number 1. هذه من الأشياء اللي we do not put it in the slides. You have to come to class, you have to watch the YouTube video. If I tell you in this problem, what is the power from the supply and the supply power factor? So what is the power? Is it instantaneous power, which is P1 plus P2 plus 3? Is it the average power, which is P1? Is it the real power, which is P1 plus P2? Is it the reactive power, which is P3?
Real power.
This is the average power. If I tell you just the word power, وأسكت, which is P equal V phasor, I phasor, cosine theta, which is I square R, which is constant.
We love average power.
We love average power. خلاص? What is the average power? What is VP?
120.
What is I phasor?
12.
My RMS. What is cosine theta?
Sin.
Cosine of minus 36.
Plus.
Or plus. It doesn't matter. لأن الكوساين is even function فما يفرق في الكوساين لما تحطها داخل ما يفرق. متى يفرق؟ في الكوساين inverse. If you put cosine minus theta it will work. If you put cosine theta it's the same. My advice is put cosine whatever angle he's putting in the example here. What is he putting? Plus 36. معناتها ان theta here 36.
He asked about the power from the source, and I would conclude that's asking about the output power.
Yes. If I tell you the word power, okay? So, what is theta?
56.
36. What is minus theta?
Minus
عشان ما نلخبط الباور فاكتور ما حيفرق. You need to understand that the current has a minus theta in it. So theta اللي هي الآن يعني خذ البوزيتيف نمبر وحطه في الباور فاكتور ريح بقى. لأن كوساين ثيتا هو نفسه كوساين ماينس ثيتا. واضح؟ Do this by calculator.
هو حيفرق لما نحسب الرياكتيف باور صح؟
Yes, it will be a different. Step by step. Can you please do it by calculator?
1.16 kilowatt.
1.16152 kilowatt or 1.1521. Note that the note here, no real power absorbed by L or C. Real power is absorbed only by R. So if you use the formula I square R, which is 144 times 8, you will get the same number. So this quantity is I square R. It is the average power that is lost in the system. To sum up this important example, always when you get I, keep in mind that this is minus theta. Okay? So whatever this angle, put it in the time domain. For the power factor, put theta. ما يفرق minus theta or theta لأن cosine is an even function.
دكتور معلش من وين نستنتج انه no real power absorbed by NRC؟
هذه معلومة حقيقية. Real power is always consumed only by resistive loads. The inductive and capacitive loads, they do not dissipate heat as a real power. ممكن يكون فيها copper losses اللي هو فيها resistive component inside the coil. This is beyond يعني the scope of the scope, but always real power is consumed by LS. Now, there are other quantities. What is VR? I times R. What is I? 12 angle minus 36.9 times R. What is VL? I want you to do VL by calculator. VL is what? I times JXL. So VL is I times JXL. What is I?
12
Angle.
minus 36.
J. What is XL? 10. Do it by calculator. All do it, please. We don't want surprises in the test. Next time, please bring calculator. Next time, please bring calculator. Next time, please bring calculator. Please bring calculator. Where? No iPads in the quizzes, okay? No iPads. Keep in mind here in the example he put for you angle 90. I told you J is 1 angle 90. Look at previous YouTube video.
Yes.
You remember we discussed it? VC is similar, but you put a minus sign. If you do the phasor representation, keep in mind that the V's are not with the scale with the I. So V is 120, this is 12. So it's not drawn to scale. But it's drawn to scale to the same quantity. يعني ال V مرسومة مع ال VR with respect to each other. ال VL أطول من ال V وهكذا. Counterclockwise negative angle, positive clockwise positive angle. For now, know how you draw them. Maybe we'll ask you in the homework to draw it using the software or by hand or whatever. You did phasor before? Vectors?
Yeah.
Did you draw vectors in physics 101? Semi. Magnitude and angle. خلاص. Before we start, let's look at this photo. So we are done with the history. We are done with the structure. We are done with what? Single phase. I gave you an example. You know how to do it. But let's jump to the three-phase system. So what do you see in this power line? 1, 2, 3, 4, 5, and then there's 3 here. There's 3 here, there's 3 here, there's 2 here. Phase A, phase B, phase C, going from Riyadh to Dammam. Phase A, phase B, phase C, coming from Riyadh to Dammam. These two are the neutral, يعني زي zero voltage, shielding wires. They neutral. So if I tell you three-phase systems and I show you this figure, does it mean an actual cable فيه له 3 sinusoidal ورا بعض? No. It means that a tower that has 3 cables going in and back, each one of the cable is carrying a phase, but we combine them together to see how far they are from each other. I don't want you to think about the actual conductor, الكيبل نفسه فيه له 3 sinusoids. It is the tower, which we call it the line, that has the 3 phases on top of each other. طبعا في أشياء في physics, do the cables impact each other? Yes, etc. So, why do we have a 3-phase system? 3-phase systems, first of all, they produces rotating magnetic field. يعني المغناطيس حقها يدور. Because it rotates, it is capable of self-start motors that are run on 3-phase basis. تخيل عندنا مروحة في البيت عشان تشغل الكهرباء لازم تدفها بيدك. Is it practical? هذه single phase مراوح single phase. Actually, there are electronic circuits, capacitors, etc. that kick off the fan if it's a single phase. But these are expensive. So 3-phase motors are self-starting. مراوح تمشي من نفسها. الشيء الثاني, for the same physical size, 3-phase generator يعطيك الباور حق 3 single phase بنفس الحجم. لأن أنت you are occupying the space حق الجنريتر. أنت لما يصير عندك جنريتر 3-phase 360 degrees divided by 320, ولا يكون عندك واحد 3. This is not the right photo. معلش. So what I'm telling you is, think about it as we're utilizing the space of the motor or the generator. You can have 5 phases. As a matter of fact, if you work with a space agency, you will see 5 phases for space industry. تفضل.
دكتور الحين ليش ال 3 phases تقدر تشغل المروحة بنفسها بينما
عشان المagnetic field حقها rotating. We'll talk about it in the machines part. But think of it 3-phase, we call it rotating, يعني مجال مغناطيسي يدور زي الMRI حقت المستشفى. Rotating magnetic field. مش fixed. And then the last point is about the lines themselves. Instead of 1 cable, you have 3 cables carrying power. so you transmit more power. And if one cable was lost due to a fault, you still have 2 cables running. So is 5 phases more reliable than 3 phase? Yes, but why we don't have it?
More
It's complicated. Complicated. As a matter of yes,
3 phase مو dangerous أكثر من ال 1 phase.
everything is dangerous. Remember the article? What was the danger?
أتكلم إنه أكثر يعني. لأن المagnetic
Well, if you touch 3 cables, it is more dangerous than if you touch 1 cable, regardless of 3 phase or single.
بس أنا أقصد حتى لأن
أنت الحين عندك هذا البرج، حطيت يدك على 2 cables. أكيد تتكهرب مرتين. ولا حطيت يدك عشان كذا الطيور لما توقف على سنجل فيز ما يصير لها شيء. It has to do with the structure حقت الانيمال ولا الإنسان. But 3 phases is just 3 cables running together. It's not 1 cable carrying 3 sinusoids.
Yes, yes.
Get it? You can have 3 single phase lines next to each other running independently and you still get the same risk. لو مسكت 2. So it's the other. Now, how in principle, how the 3 phases generated, you get a rotating magnetic field. هذا مو بمغناطيس الحالة يدور. هذا rotating magnetic field يعني مجال مغناطيسي يدور. Get it? You put 3 coils spaced by 360 divided by 3, 120 degrees. قانون الحث المغناطيسي حق لينز, this previous slide is telling you if a single coil is rotated at a constant speed in a magnetic field, an AC voltage is produced. So if this magnet rotates, current here will be AC or voltage. Current here will be AC 120 degrees apart. So this peak is 120 degrees away from this. Now, in reality, you get the magnetic field rotated by different mechanism. Sometimes they put permanent magnet, sometimes they put DC. It is complicated, but for now, think of it as مجال مغناطيسي يدور. You get 3 phases, A, B, and C. So here, for example, you have a 3-phase load, A, B, and C. You run the motor. You get 3-phase load with 400 volts. Or you can run a light bulb or an electric circuit with just a single phase. This could be class 2003, the other could be class 10,013. Is this 2004? 2004. So this could be 2004, this could be 1013. The same building, maybe. Another thing I want you to understand is each one is away by 120 degrees. So A is 0, B is minus 20, C is minus 240. Is minus 240 equivalent of plus 20, 120?
Yes.
Yes, if you rotate clockwise, minus 240 is same as rotating plus 20, 100 clockwise, the third quadrant. So you can also rewrite it as BC 120, both are correct. Let's stick with minus 240 for simplicity. So the purpose of circuit analysis, we need phasors. We love phasors in E360. So we love the RMS, we love the average power, and we love the frequency and phasor representations. Okay? Dimshi 10 or 50, I know you have it. The last slide for today is the phase sequence. This is A, B, C. If you swap the phases by some means in the windings of the generator, you may have C minus 120 away from the A and B plus 120 away from the A. So this is ACB. This is positive sequence. This is what? Negative sequence. Which one is more more visible? We see it more positive sequence in these examples, but also it is present in industry. There is lots of negative sequence. So keep that in mind if you hear positive sequence, 3-phase system versus negative The only difference is B becomes the C and C becomes the A. So instead of A, B, C, it becomes A, C, B. This subscript becomes C, this subscript becomes B. Okay? I will stop here. If you have any questions, please ask the questions. If you have my calculator, please return it. Don't forget the calculators. How many YouTube videos we had so far? This is the third one. I'll try to get this today or maybe tomorrow. It takes 3 hours of time to upload. 10 gigabytes. Okay? So sometimes I do it the other day. I get a failure in the channel and then I have to re-upload again. Any other question? Okay, have a good weekend.